Hi, everyone. Really excited to be here and talk to you about Kubernetes and platforms, two things that I really like. So the talk is titled How to Build Cloud Native Platforms. If you already built one, I would be really interested in what patterns you use, but I'm going to show you how to do this in a cloud native way. So before we start, a little bit about me. I've worked for many years with Kubernetes, Docker, Linux, cloud native stuff. So I've been around the block in startups and big companies and seen how platforms slowly become more mainstream, how they replaced DevOps as a buzzword, and now how they kind of like become even more important with the age of AI. So platforms were there in different shapes or forms. Now they are more pronounced and more there, but this is not entirely new concept. I worked at Loft Labs, where this company is a creator of products like vCluster. I lead an engineering-enabled team, which is a different name for a platform team. And by the way, we are hiring. So check out our webpage if you want to work with cool cloud-native projects. At my free time, I work with open source, and I really like tweaking my Linux, so I'm rising it all the time. The best way to contact me is to just go to my webpage, cloudrumble.net, or you can snap quickly the photo of this QR code, which will take you to my LinkedIn profile and my webpage. Okay, so let's start by defining what a platform is. It's a really overloaded term, similarly like DevOps is still and was at the early stages for sure. I like putting platform in context of what we already know. So there is something like business platforms. If you think of products like Uber or DoorDash, those are really platforms that connect vendor and end customers. So the whole product is really a platform, right? And this comprises of various services that the end user can take advantage of and conduct a business transaction. Another group of platforms are domain-specific platforms. So those mostly come in shapes of various SDKs, internal services, and they cover kind of cross-cutting functionality that doesn't really fit into any of the well-defined business domains. So you can think about maybe logging or various observability services and so on. So those were domain agnostic platforms, and then domain specific platforms is actually the ones that do fit into one of the business domains, but they don't necessarily provide the end user functionality. A good example here could be map functionality, something like Google Maps. You can embed this service into your application because you can use it in web apps, in mobile apps, in various contexts and forms. So those three buckets of levels or platforms are a good way to try and make sense of what platforms are and where they can enter. So today we're going to specifically focus on the domain agnostic platforms, which is specifically infrastructure. So how do we provide building blocks that are essential for developers, but do not translate one-to-one to actual functionality to end users? Let's briefly talk about the benefits. So we have this idea of various platforms. We know that it's needed. Everybody talks about it. We definitely want to try it, or we heard about it. So the three main benefits, there are more than three, but I kind of selected three just to set the stage here. So simplified resource management. So definitely if you have a lot of, let's say, cloud services that you want to expose to your developers, you want to simplify and standardize. So that's where platform comes in, and it can help you to provision resources in a reusable and repeatable way. The platform's main goal is really to increase development efficiency. And this really translates mostly to ensuring that developers have less friction in getting things done, because you might have heard of a famous term, shift left, meaning that developers are being more and more involved into all kinds of non-development activities. We talk security, deployment, and other things. So shifting left just by giving developers everything and going home doesn't obviously work. We need to do this in a really thoughtful way. So if done correctly, platform will increase developers' efficiency because it will remove friction from what developers do. And platforms typically internally address built-in scalability and reliability needs. So those are things like how do we run infrastructure in a way that it does scale with users, or it scales down also when the traffic goes down and so on. How do we make sure that it's reliable? So this is where we talk about concepts like SRE and similar. So platform can cater to all those needs. So building blocks of a platform, this is more of a tenets of how we would approach creating a cloud native architecture that would give us a really robust platform. So there are certain boxes that you really want to tick and think about when you create your own platform. So first one is self-service portal. I'm sure a lot of you heard about products like Backstage or Port or similar. This is simply something that sits between the developers and the broader infrastructure and enables developers or other types of engineers like testers use the platform services in a very intuitive and simple way. So this building block is not always necessary. Very often it's enough to have just a simple configuration file or an API. But once your platform becomes a little bit more broader and bigger, that's definitely where we see continuous adoption of service portals. Another tenant is programmatic APIs. And this talk, if anything, is really mostly about trying to convince you that approaching building platform like an API is really the way to go. So if you think about APIs, we can programmatically call, a RESTful service or some kind of endpoint, and this does something. That's, by the way, how all the cloud providers work. Whether it's AWS, whether it's Azure, Google, or others, they all expose an API surface that you can consume either via CLI or a UI. But at the end, those APIs are the entry points and they govern everything. So building platform is no different. We are really learning from the giants like hyperscalers, and we provide programmatic API surface for our platform control planes. Another building block is automated workflows. So platform takes a lot from the early days of DevOps and realizes that, yes, we definitely need to automate, whether it's an actual CI workflow or any other type of automation. That's where platform can standardize. So when you find yourself repeating something 3 times, or when multiple users are trying to get something by hand, that's a good sign that you should automate it. Monitoring and observability. Nowadays, we have a lot of monitoring and observability tools, Prometheus, Grafana, and so on. Platforms typically build those in and expose certain monitoring capabilities to end users. Monitoring infrastructure is difficult. However, the act of monitoring and observing your system should be intuitive and simple. Security and governance controls. This one is obviously important, but it also, from the governance point of view, you don't always want to expose all the cloud surface to your developers. One angle is security, another one is just too much. It can be confusing. Developers don't necessarily need to know every nitty-gritty setting of your RDS or queuing system. Ideally, we would remove friction by just exposing enough through these governance controls. This also talks to compliance. So again, platform is this middle part that sits between developers and all kinds of other things, be it cloud infrastructure or compliance needs. And finally, probably most importantly, platform is never really done. Similarly, like end user facing products are never done. We continuously evolve, adapt, and we treat it as a product. So those are just 6 simple tenets to have in mind when you embark on a platform building journey. Some best practices that, to reiterate a little bit more, if you specifically embrace cloud native, API driven, again, to remind you that what I'm talking mostly is about designing API first. How will my contract between developers and platform look like? What kind of API I'm standardizing on? And I'm advocating for standardizing, obviously, on Kubernetes API. A little bit more on that later. If we build cloud native, we obviously want to leverage cloud native technologies. So we talk about containers and other tapestry of cloud native projects that is continuously growing. We also want to focus on GitOps, so the way we deliver platform or deliver infrastructure changes to developers also uses GitOps. And this is something I'm going to show in the demo. Ideally, we don't want to interact with the system using any kind of CLI from our computer into the system. There are some cases when this makes sense, but in a production setting, you really would like to have some GitOps-based workflow where you have a system in between the developer and the end infrastructure. So as I'm talking about API first design, I think it's good to remind ourselves what is an API. So the definition is really that it's an application programming interface, which is a set of rules and protocols for building and interacting with software. And I highlighted here the words interface and interacting. So when you think of API, this is really about what kind of interface you're exposing to end users, namely how do they interact with platform, what you have built in. If you think about REST API or any other web APIs, there's things like retry mechanisms, there's security, so there's a whole kind of area of interface that is already built in, and you can capitalize on this. And interacting with software is important part also. So you prefer to have a platform that would interact through API with various, either with humans or either with automated processes. So we are using API as it was intended. We are just using various products and services that translate the same API-driven design into an infrastructure platform. So why it matters, to quickly recap, so obviously, we can simplify things with API and protocols like HTTP. Those are very well tested and very well known things that are secure, and we can trust that we can build on top of it. Standardize, similarly, all the protocols, including Kubernetes resource model, is something we can standardize on. Automate, scale, and secure. Here, just a quick reminder that, again, platform is a product. So if we talk about building a set of services and an API surface for developers, we really treat it as a product. So similarly, like the simplified diagram, we want to understand the developer's needs. We want to design something and test, implement a minimum viable product, deliver it, and gather feedback and improve and repeat the whole process. Similarly, like we would do with any product. So now we are going to jump into a demo, which will show all those design principles in action. So remember, our goal is to empower developers to be able to use our platform in a frictionless way. We want to use cloud native principles and make sure that our platform is API driven and leverages things like GitOps workflow. So now let's transition to a quick demo. Here I have an Azure portal. You can see that there are some resource groups, one that wants to be deleted, and others. Nothing crazy here, just a regular Azure portal. So I am now playing a role of a platform engineer. So I take care of this portal. Developers don't really need access to it just yet. I set everything up. I am roles, all the permissions, everything is great. So that's the first kind of entry point. Now, as a developer, what I really care about, I care about this code. So this is my world, right? As a developer, I'm switching hats now and become a developer. The code is less important what it does, but the code is what I'm focusing on. So I'm interested in writing my code, testing it, making sure that it works, and continuing developing new features. I obviously have to consume infrastructure because almost every program that I write will need to be somewhere. We need to interact with the database or do something interesting to actually be useful. For the intents and purposes of the demo, let's imagine that I'm not that much into cloud native or Kubernetes, and my knowledge about containerization ends up with a simple Docker file. So maybe someone from platform team helped me create it, but I just have a Docker file, I Dockerize my application, and I send it off. So what this application does, it actually creates Azure infrastructure and it reads data from Azure Blob Storage. If you don't know what Azure Blob Storage, this is like S3 bucket in AWS. So it needs infrastructure in order to function. So now as a developer, I want to actually deploy everything and test it, but I don't have anything. I don't have Azure Blob Storage, I don't have Azure infrastructure, and I don't have my application deployed. So how do I go about it? So here, let's hope that demo gods are with us and it will all work as always with live demos, but that's interesting, right? So the first part, if you remember, I talked about service portals. So this portal is called Port, and this is a service portal for me as a developer. So if I want to create the infrastructure I mentioned and deploy my application into Kubernetes cluster, the only thing I have to do is have to click this create action. So when I do this, it asks me for a few inputs, things like connection string variable, where is my image or what it's named, and port. So I'm happy with all the default things and I execute it. So when this is executed, behind the scenes, what's happening, port is actually creating a pull request. So this is another thing we talked about, that we are using Git and GitOps practices rather than allowing developers to interact directly with everything else. So if I go to this repository, which holds my deployment manifests, hopefully we have a pull request now. So you can see a pull request arrived, and this pull request has been opened by the action I clicked. So I clicked this create, and then port behind the scenes created a pull request. This pull request is automated. So as a platform engineer, maybe I want to check if everything is okay. This step is obviously optional. I could fully automate the pull request if I would know that developers maybe just want to test something. So let's imagine I reviewed it thoroughly. I'm going to show you what this pull request does. So this pull request, a little bit bigger, it creates this simple YAML file. So as you notice here, this YAML file actually follows Kubernetes API. So it has API version, it has kind, and it has metadata and other things. So this is our standard that we're embracing. We say the way to interact with our platform is to use Kubernetes style API. But if you know Kubernetes as a container orchestrator, you can say, well, what's the point, right? How can this actually result in creating resources? So we are using Kubernetes here not as a container orchestrator, but we are using it primarily as a control plane. So Kubernetes controls and have control loops that make sure that the desired state that I am submitting here in this file is going to be resolved as an actual state somewhat somewhere. So this file, you notice that we have this connection variable name, image, and port that we've taken from the input here in port, but the namespace, for example, wasn't available as an input value. So this is something hard-coded for my developers. All right, so before I click approve, I want to show you one more application. So here I'm switching hats again. And this is Argo CD. If you're not familiar, Argo CD is a GitOps tool. I think one of the most popular, this and Flux are two tools that essentially observe at one hand a Git repository and at the other hand connects to Kubernetes cluster, one or more, and take the state from the Git repository and actualizes it into a cluster. So far, we just have this empty Bootstrap application, and this Argo CD instance observes this very repository. So when I finally merge this file, so I reviewed it, let's delete the dangling branch. And here I'm going to refresh it. And you can see that things starting to pop up. So something is happening, right? We have app claim, app, and various other resources like unfold out of this action that I've taken. So based on this small file, we are starting to have things like resource group. There's some releases, objects, container, account, and other things. Developer didn't need to specify those things, but they actually happen. So let me show you real quick in Azure. Remember, that's the view that we've seen earlier. When I refresh it, I should be able to see a new resource group, which is called Platform Demo. And that's the one that we are currently creating. So Kubernetes, in this case, is talking to Azure and is creating resources in Azure. And you can see here, I have a little notification from Slack. So as a developer, I triggered this process. I created this PR through here. Someone from platform approved it. And now part of this process was to create a Slack notification for me saying that my app is deployed to localhost. I also have my own dedicated observability, and I have something called vCluster. So from my perspective as a developer, I clicked the button, went to grab a coffee, came back, and everything is ready for me to test. So we can see real quick also here. You can see this is K9S, which is a Kubernetes viewer. And on top here are all the resources that are being currently rendered inside of my Kubernetes cluster. So what is happening with those resources? They correspond to actual infrastructure in Azure and also into Kubernetes resources that have been created. So you can see we have created a namespace, ingress, deployment service, and we've created all kinds of Azure infrastructure just based off of this small file. So if I click to localhost, you can see that this is our Azure Storage Blob Reader. Remember, as a developer, when I looked here in my app, that's what I want to do, right? So this is my application. I wanted to deploy it, and this application is currently deployed and running. So let's see if it's working. I can already see that it's working, as in it displays what it's supposed to display. But let's imagine that I want to just read the content of a blob file. So it says connected, but no documents found. So let's create one document. So here I have my apps deployment repository. And here you can see I have an example folder. And in this example folder, I have a file that looks like this. So it's another Kubernetes API style file. So I have API version, kind blob, an example, and you can see that it has hard-coded the name of my storage account. So now I don't need to use GitOps because I really want to quickly test it. So let's do the same. I am going to do K for kubectl, apply, and then -f, example, and blob content. So I'm again using the same paradigm that we've been discussing earlier, API-driven platform, API all the way. So what this should have done, this should have created the actual file inside of the Azure storage. And if I refresh the page, there you go, hello chip 24. It even supports emoji. We can definitely sell it. This is great. All right, so you can also see that all the resources in the meantime are created in Azure. I have my platform storage and everything works as expected. So there were a few more things that, as a platform, we provided to our developers. You can see this link to Grafana. So maybe I want to do some performance tests or just simply observe how my application behaves. I don't need to open a ticket. It's something I can do. I need to type the password correctly. There you go. So again, super simple. This is just scoped to my DevOps team, and I can already see some feedback about performance and various observability metrics. And finally, part of this is also vCluster. If you don't know what vCluster is, this is a virtual Kubernetes cluster. So you can put a Kubernetes cluster inside of Kubernetes cluster. So why would you do this? And this comes from experience with just working with platform. It's very often what happens, you provide a thing or a service to developers, and then they want something more. They want, oh, I want to experiment with X, right? So in order to avoid kind of keep on following up with various tickets and so on, we are giving developers their own virtual Kubernetes cluster. So I can copy this command, and then here in the terminal, anywhere, I can go and you can see that I am pointing now to the kind cluster. But if I do this connect, this will go and connect to an existing virtual cluster dedicated only for my team and for the developers that have created and opened this specific this specific app. So you can see the kube context changed, and now we are in virtual cluster. So as a developer, I have full admin level permissions on this virtual cluster. We might not want to give those permissions on the actual cluster. And then I can create anything I want here. I can create ingress controller. I can install CRDs or global scoped resources. So this takes care of an immediate need of developers by providing them infrastructure and enabling them to test, providing observability tools that are tailored to their needs, and also at the end, giving them a fully fledged virtual cluster. So we can swap back to our actual local kind cluster. And okay, so as a developer, I am done with testing. Everything went great. My application supports emojis and the background is awesome. I'm happy with it. So now I don't need this infrastructure. I don't want to incur any costs in Azure. So how do I remove it, right? And you probably might have guessed by now, there's another action in my portal that says remove. So I can select this remove action. I need to select appropriate service. This is the apps deployment. And as a security measure, I have to actually provide a name of the file that that I want to delete. So in this case, this is our little storage YAML right here. So I can copy it, go back to port, provide it, and click delete. So you probably guessed it by now what's happening behind the scenes. Port is creating another pull request, and this pull request is going to soon be ready. As a platform engineer, again, I can approve it, review it, and when it's reviewed, you can guess what happens. All the resources are going to be removed. So everything that developer developed, including cloud infrastructure and the app, is going to be cleanly removed, and we don't need to worry about additional costs. So I'm merging this pull request. It simply deletes the file. And let's quickly see our Argo. So you remember our Argo CD had those various objects. When I refresh, this should start disappearing, and it disappeared from Argo. And you can see now here, those objects are slowly also starting to disappear. I have ready false, and they already retract, and they're already being deleted. And also here on my K9S instance, all my Kubernetes resources are being deleted as well. So very cleanly, we're able to remove everything, and the platform kind of expands and contracts as the developers need. Okay, great. So as a developer, I'm happy because I am able to deploy my application in a frictionless way. I don't need to open tickets. I have a very simple process to port. I know where to log in. I know what to click, and I can keep on focusing on developing features. And as a platform engineer, I ensure that we don't expose cloud services to developers if not necessary. So we have this single kind of, we don't have a single point of failure, and we have security in depth and the principle of last privilege. Okay, so I can show you also that this should be gone. So the platform demo is still there, and it says that this is currently being deleted. So everything is done, and we don't have to worry about it. All right, so let's go back to the presentation real quick and do a quick recap. What just happened? So we have used various tools to make this process work. So first of all, as I mentioned earlier, we used Kubernetes, but not as a container orchestrator, but we used it as a control plane. Kubernetes was controlling everything and making sure that the desired state that is in the Git repository is properly propagated and keeps being propagated into a cluster. We also used vCluster that enabled our developers to keep on experimenting and actually have their own fully fledged virtual Kubernetes cluster so they don't follow up with a lot of requests. The magic behind the scenes, which took care of creating an actual infrastructure, is a project called Crossplane. So Crossplane, similarly like Terraform, can talk through an API and create an infrastructure, manage infrastructure, in our case in Azure. But the added benefit is that it keeps the infrastructure up to date because it utilizes Kubernetes control loops and makes sure that we can actually keep on having the infrastructure being updated. Crossplane, similar like Terraform, has various providers, and we took advantage of provider HTTP, for instance, to integrate with our Slack notifications, and we used all kinds of other things. Port that you've seen at the beginning, this is a developer portal. Alternative to it is Backstage, but those tools are very useful for especially bigger deployments for bigger platforms. Now, interestingly, we use GitHub in a way that I think it's really, really nice in terms of self-service. So we use GitHub PRs almost like messages in messaging queue. So the PR is actually an actionable chunk of work that it carries some action with it, and you've seen me approving the PRs and reviewing them. You can, of course, add more elaborate approval processes or remove them completely, which would remove the friction from the developer workflow. And we have here Argo CD, which is a GitOps workflow. And believe it or not, all of this we're running on my local Kubernetes cluster. You can, of course, put it in a regular cluster, and that's how it would work. So just to quick recap visually, if you like to learning more visually, as a developer, I connected to IDP, in this case port, and then I access it through UI. I pushed a change, so I clicked create. This change was synchronized with a Git repository. As a platform engineer, I approved it. Once approving the changes, the Argo CD pulled the changes from the Git repository, synchronized them to Kubernetes API, and Kubernetes API using Crossplane gave everything to Crossplane, and Crossplane in turn created vCluster application as well as cloud services. So in conclusion, we reduced friction for developers to almost zero. If we would have removed the need for PR, that would actually be zero, because developers don't need an external third party to achieve what they want. There's no waiting time, so we didn't open a single issue or ticket. Everything was automated. We used GitHub PRs as an interface between platform engineers and developers. So this was obviously easy to collaborate, and we also increased security by introducing zero trust principles. So there was no Azure access needed by developers. And I didn't even mention AI once, which is great. All right. So the key takeaway from this talk is to be able to design your developer portals like APIs. So if you think about API and the contract that API incurs, that would exactly be a great thing to do. So I think I'm exactly in time. Thank you all for your attention. If you have any questions, you can check out my webpage or connect with me on LinkedIn. And this QR is to a source code for the demo. Everything is open source available. You can copy cross-plane compositions and play around with it yourself.
Thank you very much. Awesome stuff. That was really cool. So if you have any questions, you can go ahead and post them to the comment section. Make sure to use the hashtag Ship24 as part of that. Of course, I will remember not to do that myself because otherwise I will be in the draw. Lots of good feedback here. So Joanna's a fan. So is Doug. There's a comment here from Josh. The fact that you're using this to deploy developer platforms is awesome, but what if we generalize this pattern? You're using GitOps and Kubernetes for order fulfillment. It seems like there's a lot of potential here.
Absolutely. That was just an example of like fun application to show, but you can do this with the real life applications, and there's plenty of examples of utilizing Kubernetes operators patterns to do exactly that. Good
Do you think
observation.
about this like Kubernetes at the edge sort of approach as well? I know that, for example, Chick-fil-A is a classic example that's talked about a lot, using developer platforms and Kubernetes at the edge for doing deployments in that manner.
Absolutely, yes. That's also part what vCluster kind of does. You can run this in the sense that you package Kubernetes inside of Kubernetes, which is very similar to having a use case on the edge. And edge is really cool now with distributions like K3s or like very, very small. And with introduction of technologies like eBPF and WASM, that opens up even more possibilities. So definitely a really exciting area here.
If you want to find out more about Port, you can go to getport.io. This is the homepage for that. Love their design, which is great. I'm a big fan of developer portals. I've been using Backstage. We actually have an integration with Backstage from the community for Octopus deploy, which is kind of cool. I have to spend more time with this. The other one is Crossplane. You mentioned this, very similar to Terraform. These tools are immensely powerful. The hardest thing I have is understanding the whole ecosystem. So if you go to something like landscape.cncf.io, it's like my browser almost crashes every time I try and load this thing. So I mean, how do you keep tabs on all of this stuff? Is my sort of rhetorical question. But do you find it overwhelming at times?
I used to find it overwhelming, but to now I don't really look at it that much. So I have like few projects that I know about, and I know that what projects to use. And if I need something, then I maybe search for it. But if you really look at it, if you make it your wallpaper, yes, this can give you a headache, and that's not a good use of your free time.
No, it's not. No, it's not.